Hey there, welcome to the video guys. My name is Pushpinder Gill. So in this video, we're going to be talking more about the trigonometric functions, right? So what we're going to do is we're going to derive some very important results uh, which are there in the trigonometric functions, which will actually lead up further to more important results. So what I'm going to do is I'm going to start with two axes here. Let's suppose this is the x-axis, right? And this is the y-axis, right? So we're going to draw a circle with radius 1 unit. So we're going to draw a circle with a radius of 1 unit. Let's suppose this is that circle. This is the origin and also the center of the circle. And this is a point P right on the edge of the circle with coordinates a comma b, right? Which means the distance from here till here is equal to the y coordinate, which is b, and the distance from here till here is equal to a, and this is something which I'm joining this, and this is equal to 1 because the radius of this circle is equal to 1. So we have actually taken the radius of this circle to be equal to 1, right? And this is equal to x degrees, the angle x here, right? And this point over here, it's going to be 0 comma 1 because the radius of the circle is 1. This is going to be 1 comma 0. This over here, it's going to be 0 comma negative 1, this point right here. And this point right here, it's going to be negative 1 comma 0, right? So we have actually set up this this equation over here, right? So let's move forward. Now if we know that let's say this is point M, this is point A, let's say this is point B, this is point C, this is point D, right? Now from here we already know that this is actually a rectangle with 90 degrees, right? So if we kind of use the sine cos tan property, so you know that sine cos tan, it's something this. So sine theta, it's going to be equal to, so if I kind of it's like this, I'm just gonna get a different pen here so that we understand it in a better way. Sorry about that. So if we kind of use the value of sine theta and cos theta here, now what is the value of sine theta, or let's say what is the value of sine x? Now sine x is nothing but which is equal to, so sine x is equal to perpendicular over hypotenuse. So the perpendicular here, it's b, so you can see the perpendicular is b, divided by the hypotenuse. The hypotenuse is 1, and cosine of x, it's equal to base over hypotenuse. So the base over here is a and the hypotenuse is 1, so I'm just going to ignore that. So from here we know that sine x is equal to b and cos x is equal to a. Now we know that using the Pythagoras theorem in this triangle, using the Pythagoras theorem in the triangle O, P and M, we know that a square plus b square is actually equal to 1. So we know that a square plus b square is equal to 1, which means from here substituting the value of a as cosine x, I'll have cosine square x plus substituting the value of b as sine square x to be equal to 1, right? So this is the first important result that you need to remember when it comes to trigonometric functions, that the value of cosine square x, let x be any value, and the value of plus value of sine square x is always equal to 1, where x is the angle which is there, right? Any angle, x can be any angle, doesn't matter whichever angle you take, it is always going to be a right angle triangle, and in that case a square plus b square is always going to be equal to 1. And using this expression here, that sine x is equal to b and cosine x is equal to a, let's suppose if I want to find the value of some standard values for cosine and sine. So let's suppose if I want to find the value of 0 degrees, right? So let's suppose I want to find the value of 0 degrees. When it comes to 0 degrees, this line is what I'm interested in. Actually, this point is what I am interested in, which is in 1, 0. In that case, the value of A is 1 and the value of B is 0. And we already know that B is equal to sine of x and A is equal to cosine of A, which means the value of cosine of 0, it's going to be equal to B, which is actually equal to which is equal to A, which is going to be equal to 1, and the value of sine of 0, it's going to be equal to 0, which is equal to A. In another case, let's suppose if I want to find the value of the next case, let's say I want to find the value of 90 degrees, right? In 90 degrees, I'm actually interested in this point, which is in 0, 1. In that case, A is 0 and B is 1. Hence, cosine of 90 degrees is going to be equal to the value of A, which is actually equal to 0, and the sine of 90 degrees, it's going to be equal to B, which is equal to 1. Similarly, the next angle which I'm interested in is this one here, which is equal to 180 degrees, right? In this case, I'm actually interested in this point, which is in minus 1, 0. So this is A and this is B. In that case, the value of cosine of 180, or you can even call it 180 to be pi, cos of pi, is actually equal to the value of A, which is equal to negative 1. And the value of sine of pi, that is sine of 180 degrees, is actually equal to B, which is 0. Similarly, the next angle which I will be interested in is in this one, which is 90, 90, 90, which is 270 degrees, or you can even call it 3 pi by 2. So I'll just call it 270 degrees. So in that case, my points are 0, negative 1. So if this is A and this is B, so in that case, the value of cos of 270 is going to be equal to 0, and the value of sine of 270 is going to be equal to negative 1. And the last angle is of course 360 degrees. So I'll let you have this one. This is 1 and 0. So this is A and this is B. The value of cos of 2 pi or 360 is actually equal to 1, and the value of sine of 2 pi, which is 360, that is equal to 0. Right. So these are the values which we have here. Now, as you can clearly see, that cos of 0 was 1 and cos of 2 pi was 1, and the sine of 0 was 0 and the sine of 2 pi was 0. That means the function is repeating itself after 2 pi. That means what is 2 pi? 2 pi is actually exactly 1 revolution, and that means we can say that the cosine function and the sine function repeats itself after 2 pi, right? So it kind of repeats itself after 2 pi. Let's talk about the sine function first. That sine function is actually repeating itself after every 2 pi. So it was sine 0 degrees at 0 degrees, and then it's 0 at sine 360 degrees, which means I can say that the value of sine 0, it's actually equal to the value of sine 360, which is equal to the value of sine 360 into 2, that is equal to the value of sine 360 into 3, because it is going to repeat itself after every 1 revolution. So instead of 0, if I write the x value, if I say sine of x, it's going to be equal to sine of that is x plus 360, let's call it 2 pi, then that is equal to sine of x plus 2 into 2 pi, so and so on, which that is equal to so on. So if I kind of generalize this, I can say that the value of sine of x is equal to the value of sine of 2n pi plus x, where n is an integer, right? So where n is actually an integer, right? So I suppose you're understanding what I'm trying to say here. This expression is again a very, very important expression. So I'm going to write it down as the second important expression. And the third one is the same thing is actually followed for cosine of x as well. That is, cosine of x is actually equal to the cosine of 2n pi plus x. Again n is actually an integer, right? So same thing happens to this function. I suppose you've already implied that, you've already seen that. Now another thing is, another important point here that I want to illustrate is, when is the values of the sine function and the cosine function equal to 0? Now when is the value of sine x is equal to 0? So as you can clearly see in the previous thing here, that sine x is equal to b, which is actually equal to the y coordinate. And you can clearly see that the y coordinate is equal to 0 after every multiple of pi. You can clearly see it's going to be 0 on this x-axis here. It's going to be 0 on this x-axis. That means at 0 degrees, at 180 degrees, at 0 degrees, at 180 degrees, at 360 degrees, the value of cosine is going to be 0. 0, 0, 0. That means it's going to be 0 after an interval of pi or interval of 180 degrees. That means if sine x is 0, x is actually a multiple of pi. Again, n is an integer, so this is again an important expression that you need to know. And when is the value of cosine function 0? Again, cosine over here, it's actually equal to the x coordinate, which will lie here. The value of x coordinate would be 0 here. So that means it's going to be 0 at 90 degrees, and it's going to be 0 at 90 degrees, then it's going to be 0 at 270 degrees, and so on. So it's going to be 0 at 90 degrees, 270 degrees, and so on. So what is 90 degrees? And again, 90 plus 180 is 270 degrees. And then this plus 180, it's, if you just add 180 to it, you'll have 450 degrees and so on. So how do we actually generalize this in terms of pi? So this is nothing but pi by 2. And this is nothing but 3 pi by 2, that is 270 degrees. This is nothing but which is 5 pi by 2. So that means you can clearly see that if cosine of x is equal to 0, x will actually be equal to 2n plus 1 into pi by 2, right? So this is 1, 3, 5. So the next number would be 7 pi by 2. So which is actually an odd number, right? So this is when the value of cosine x is actually equal to 0. Right. So in the future videos, we're going to be understanding the sine function and cosine function in a more better way. We're going to be actually doing the graph of the sine functions and cosine functions. But yes, these are the important points that you need to know when it comes to the trigonometry functions. There are a few other functions that I would actually like to illustrate here. Some of the common notions that you should know, that is the reciprocal of functions. Now we actually have defined the value of sine x, and we have defined the value of cosine x. Now based on these two parameters, we can actually have a lot of things. So the first thing that we can have is the cosecant of x, which is actually equal to the value of 1 over sine x. Now understand that this denominator here cannot be 0, which means the value of x cannot be a multiple of pi. It cannot be a multiple of pi because this cannot be 0. So cosine of x is not defined for these values. So the value of sine x cannot be 0, because then this would become undefined. The second thing that over here we have is the secant of x, which is equal to 1 over cosine x. Now in this case, again, cosine x cannot be 0, which means x cannot be equal to 2n plus 1 into pi by 2. Right? So something like that, because cosine x cannot be 0. So this expression here cannot be equal to this. The third thing over here, it's actually equal to the tangent of x, which is equal to the ratio of sine x over cos x. Again over here, cos x cannot be 0, which means x cannot be equal to an multiple of 90 degrees, right? It's not a multiple of 90 degrees, it's 90, 270, and so on, right? Same thing over here. The next fourth thing is the cotangent of x, which is the reciprocal of tangent of x, which is also known as the cosine of x over the sine of x. Again, since sine x cannot be 0, so x cannot be a multiple of 180 degrees, right? So I suppose you've understood all these four identities here, and so that's there. Now there are few Now, there are few important angles that you need to know. There are few values of the important angles that you need to know in when it comes to trigonometry functions. And there is actually a very easy way to remember those angles. Now, I'm going to show you those that easy way. So, how you actually draw that table of finding the important angle. So, you're going to write down 0 degrees and you're going to write down 30 degrees. Then you have 45 degrees, then you have 60 degrees, then you have 90 degrees, right? So what you're going to do is you're going to write down 0 1 0 1 2 3 4. You're going to divide each thing by 4, just like that, and then you're going to square root everything. Now this is actually going to come down to the value of sine. So the value of sine 0 is 0 by 4, which is 0. This is 1 by 2. This is 1 by root 2. This is root 3 by 2. And this is 1. So the value of sine 0 is 0. The value of sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. Sine 90 is 1. And cosine is actually the reciprocal, the inverse of sine. So this one is going to be written here. This root 3 by 2 is going to be written here. This 1 by root 2 would be written here. This would be written here. And this would be written here. Right, so this is the cosine of x. Cosine of 0 is 1. Cosine of 30 degrees is root 3 by 2. Cosine of 45 degrees is 1 by root 2. Cosine of 60 is 1 by 2. Cosine of 90 is 0. We're going to understand the reason behind this in the future videos. Right now, let's just understand how the table is formed. And the tangent of x is nothing but, which is the division of sine x over cos x. So 1 over 0 is nothing but 0. This over this is nothing but 1 by root 3. This over this is nothing but 1. This over this is nothing but root 3. And 1 over 0 is nothing but not defined. So this is how you draw the table. Just write 1, 0, 1, 2, 3, 4. And then you divide by 4 and then you take the under root all over. Now the values of cosecant x, the values of cosecant s, secant x and cotangent x is something that you can find out by reciprocating sine, cos and tan, right? So that is something that you can do. Fine. So suppose you're understanding this point here, guys. This would be the website to explore more about us, and this would be the Facebook page to give us your valuable like, and this would be the email address to send us your valuable feedback. So that would be about the video, guys. Thank you very much for watching, and I'll see you